Okay, hello again, everybody. It looks like we're ready to start the last topic of this current chapter, and the topic is equations of lines. So we have two types of equations of lines, two different forms that we'll tell you about today. There is another one that we'll see later on in the year, but we're going to start out with one that you already know, which is the slope-intercept form. Slope-intercept form of a line. This is the most well-known one. And it is y equals mx plus b. So what you need to know about this form is that whatever number is in front of x when your equation is in that form, that is going to be the slope of your line. Remember, m stands for slope. And the b is the y-intercept, and so remember that that's where your line will cross the y-axis. I don't know why it's called b either. So hopefully you had that already in Algebra 1 or maybe even in Algebra 2. Another form of the line we're going to have in this lesson is called point slope. We'll do examples of these here in a bit. Point slope form. So that one is y minus y sub 1 equals m times x minus x sub 1. Okay, so in this form, the m is the slope again, and the x sub 1 and the y sub 1 are coordinates of a known point. So you know that point, you know the coordinates. And the x and the y are just variables. Okay, I should probably talk about where this one comes from. So this formula, this form comes from the slope equation. So slope equals, remember, y sub 2 minus y sub 1 divided by x sub 2 minus x sub 1. So we use that formula to calculate the slope of a line. So if you just take that and multiply both sides by the denominator, you'll have y sub 2 minus y sub 1 equals m times x sub 2 minus x sub 1. And then to make it one more step so that it looks like our point slope form, we're just going to replace y sub 2 with a generic y, so just a variable. So y minus y sub 1 equals m times, and then same thing for the x sub 2, we're going to replace that with a variable x. And so in that equation, again, x sub 1, y sub 1 is a point that you know, and oops, I forgot the m there. Let me put that in there. M is the slope of your line, and then x and y is just any point on the line. So x and y are variables in that case. We have two more forms. So this is a special case. This is whenever you have an equation, x equals some number, like x equals 5, that's going to be a vertical line. We'll talk more about that later. And then another special case is whenever you have something like y equals a constant, y equals negative 2, that's a horizontal line. We'll also have standard form of line, which comes in later. Okay, so let's, I guess, get right to it here for the examples. So example number 1 is to write an equation. So we're doing a lot of writing of equations. So write the equation of a line with slope 3 and passing through the point 2, 1. So that's our known point. And we're going to stipulate that this equation is in slope-intercept form. So that's what it's going to look like at the end. Okay, so there's different ways to do these problems, but if I see a point and a slope, I'm going to immediately grab for the point slope form. So that's y minus y sub 1 equals m times x minus x sub 1. Because I know I can use all those numbers in that equation really just directly. So I'm going to plug in, so y minus, so y sub 1 is the 1. That's the y coordinate that you know. M is obviously the slope, which is 3. And then x minus, oops, I copied that wrong, x minus 2. So the 2 is x sub 1, the 1 is y sub 1, and the 3 is m. And the x and y do not get replaced by anything. They're going to be in your final answer. Let's go ahead and solve it for y because they want this equation in slope-intercept form. So to solve this for y, we'll first of all distribute that 3. And then we'll go ahead and add that 1. So we got y is equal to 3x minus 5. So that line right there with that equation passes through the point 2, 1 and has a slope of 3. You can see it as a slope of 3 right there. It's the number in front of x. But if you put in the point 2, 1, if you put in 2 for x and 1 for y, it would make the two sides of the equation equal. You could do that as a check. Okay? Okay, example number 2. So this time we're supposed to write the equation of the line. Write the equation of the line. Which passes through. This time they're going to give us 2 points. So passing through the point 0, 4 and negative 1, 2. So we don't, it's not necessary to graph these. You certainly could. But notice that we have different given information. This time they gave us 2 points instead of a point and a slope. And so they're also going to request that this is in slope-intercept form. So it's going to end up y equals mx plus b. Okay, so we can get the slope of this line just by using our slope formula. So slope equals, subtract the y, so 4 minus 2. Subtract the x is 0 minus negative 1. So 2 over 1, so that slope is 2. Now let's think about this. So we have a point and a slope. Actually, we have 2 points and a slope, so we can use our point-slope form right now if we wanted to. But let's take advantage of the fact that we know that one of our points is a y-intercept. So 0, 4. We know that's a y-intercept because the x-coordinate is 0. 0, 4 is a point on the y-axis. So if we know a point and the y-intercept, we could just go directly to y equals mx plus b and make those substitutions. Because we know m, that's the slope, that's 2. So y equals 2, x, remember y and x are just part of your equation, plus b. Well, the y-intercept is b. Well, we know that's 4, so we can just go directly to that equation because one of our 2 given points happen to be a y-intercept. That does not always happen. If that did not happen, I probably would have just started out with point-slope form. That's example 2. Let's look at example 3. So this time, same thing, write the equation. Same thing, write the equation of the line. with x-intercept of 2 and y-intercept 3. Okay, let's think about this. So if the line has an x-intercept of 2, that means it crosses at 2, 0. So that's 1 point on your line. If the line has a y-intercept of 3, that means it crosses the y-axis at 3. So 0, 3 is a point on your line. So now the problem is just like the one that came before. Let's calculate the slope of this line. Subtract the y, so 3 minus 0. Subtract the x's, 0 minus 2. So it looks like our slope is going to be negative 3 over 2. And again, we can take advantage, and this, I guess this has happened twice now. We know a y-intercept, so we can go directly to our equation. By the way, this should have been in slope. I should have mentioned this is in slope-intercept form, because sometimes they might ask you for different forms. So this is in slope-intercept form. So again, that means it's going to be y equals mx plus b. And we have everything we need to plug into that. So we have the slope now is negative 3 over 2. So we have y equals negative 3 over 2 times x. And now we know the y-intercept is 3. They told us that, so plus 3. So we took advantage of the fact that one of our points was the y-intercept to shorten up our work a little bit. We'll get a lot of practice on this on the assignment. Okay, now we also got to get into graphing a little bit here. So let's get some graph paper out. We'll graph 4 lines here. So first example is to graph y is equal to 3/2 x plus 3. Now, when you first learned how to graph, your teacher probably said to make a table, make a t-table or a t-chart, and you'd plug in x's, and you'd calculate y based on the equation, and then you'd plot the points. Well, we don't have to do that anymore if we know how to graph the equation of a line. So if we look at this, remember, you know 2 things. This is the slope. That's the slope. It's a number in front of x. This is the y-intercept. That's going to be the first point that you plot. Okay, so I'm going to put that point 0, 3. That's your first point. You don't do anything else first. That's the first thing. You put that y-intercept on, and then use your slope to calculate another point. So the slope, remember, is rise over run. So we're going to rise 3 and run 2. So start at your y-intercept, go up 3, 1, 2, 3, and right 2. You can do that all day, 1, 2, 3, and right 2. Now, because 3 over 2 would be the same as negative 3 over negative 2, would be the same, wouldn't it? You can also go down 3 and left 2. So there's a point. And again, you can do that all day. So when you think you have enough points on your line, on your graph, go ahead and connect them all. They'll be on a nice straight line. And there's your graph. So notice that we made that graph from the equation without making a table. Okay, that's all good. What if we have this next equation? What if we're supposed to graph y plus 3 equals negative 2 times x minus 1? So to graph an equation, we want to get it in slope-intercept form, which basically just tells you to solve it for y. So let's solve this equation for y. So y plus 3. So distribute that negative 2. Subtract 3. So here's our equation we're going to graph. Y equals a negative 2x minus 1. Here's your coordinate system. And remember what we did. We said we're looking at two numbers. And those numbers are the y-intercept, which is -1. So we can put that point right on there. We know the slope is -2. And remember, you can write -2 as a fraction. -2, put that -2 over 1. If you have an integer there, just write that as a fraction so you can see this, the rise and the run. And then just from here, you're going to go down 2 and right 1. Down 2 and right 1. Don't forget, you can also write this fraction as +2 over -1, that they're both equal to -2. So that means you can go up 2 and left 1 as many times as you want. Once you have those points on there, go ahead and connect them and make your lines. So there's your graph. Again, we did not make a table. We just, first of all, put that equation in slope-intercept form and then picked out the slope and the y-intercept, and we were able to graph it. Okay. Okay, now we got our special cases. Let's look at our special cases. Special case number, equation number 3, x equals 3. We already said that's a vertical line, but why don't we take a look at that a little bit closer. Why is that a vertical line? Because people are going to get confused. X equals 3, is that vertical or horizontal? Well, notice that in this equation, y is not specified. So what we can do is draw all the points which have an x-coordinate of 3. So we don't know what y is, but there's a point with x-coordinate 3. 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 So these are all 3 whatever. We don't know the y-coordinate. I mean, we can find them. So right away you see that the graph of x equals 3, why that's going to have to be a vertical line. Because all the points on that graph have an x-coordinate of 3. So x equals 3, x equals any number is a vertical line, special case, graph. Let's investigate a little bit further where y equals a constant. So let's say we want to graph y equals 4. Again, I'm going to put some graph paper up here. And let's put some points on there on the graph where all the y coordinates are 4. Where's y 4? Well, y is 4 right here. Y is 4 right here. Y is 4 right here. Because keep in mind, this is like whatever comma 4. This is whatever the x is comma 4. Well, you could find it, but the really important point is that that y coordinate is always 4. So y equals 4 is a horizontal line. Because every point on that horizontal line, every single point on it, has the same y coordinate, namely 4. All right. We got 3 last kind of examples that should go pretty quickly, and that'll wrap up the notes for equations of lines. Let's go back to plain paper. And here's a question for all 3 of these. I got 3, but they all are the same directions. Question: are the 2 lines parallel, perpendicular, or neither? Okay, so in our problem here, I don't know what number we're on, doesn't matter. I'll call it 5. Here's your 2 equations. So y equals 2x plus 3. Your other equation is y equals 2x minus 1. So you can answer this question without even drawing the graph. Look at the 2 equations. They both have the same slope. but they have different y-intercepts. And remember, we have a theorem that says that lines with it, which have the same slope are parallel. So without even drawing the graph, we know that these are parallel lines. Because they have the same slope, but different y-intercepts. If they had the same slope and the same y-intercept, they'd be the same line. Okay, going to that number 6 then. One equation is y equals 3x minus 5. Another equation is 6x minus 2y equals 10. Well, it's hard to know right now, so what we have to do is put that second equation in slope-intercept form, which just means solve it for y. So I give you negative 2y equals negative 6x plus 10. Just subtracted 6x. Oops, why did I write that? It's plus 10. I just subtracted 6x from both sides. Now let's divide by 2. So now we get y is equal to, divide by negative 2, positive 3x minus 5. Now take a nice hard look at this first equation. And after we took that second equation and solved it for y, put it in slope-intercept form, it turns out to be that they're the same. So those are the same line. They're not parallel and not perpendicular. They're just the same line. They coincide with each other. Okay, let's do one more of those, and then we'll wrap it up. Number 7. Is y equals 2/3 x minus 5. It's one of your equations. The other one is y equals a negative 3/2 x plus 2. And again, without graphing, we should be able to tell whether or not those lines are parallel, perpendicular, neither. So if you look at them, they don't have the same slope, so they're not parallel. But look at the slopes there. They're opposite reciprocals. So if you look carefully, right here, that slope is 2/3. That slope is negative 3/2, so those are opposite reciprocals. So you might remember that when we have perpendicular lines, they have opposite reciprocal slopes. So that tells you that these lines are perpendicular. I forgot to write, these were neither up here. Because they were the same line. And up here they were parallel. Okay, so what do we need to know out of this lesson? We need to know slope-intercept form, y equals mx plus b, where m is the slope and b is the y-intercept. You need to know point slope form, y minus y sub 1 equals m times x minus x sub 1, where x sub 1, y sub 1 is a point that you know on that line, and m is the slope. We need to know that whenever you have x equals some number, there's no y in that equation, just x equals a number, that's going to be a vertical line where all the x coordinates of the points are the same. Whatever that number is, x equals 5, all the x coordinates of that line, points on that line would be 5. And then horizontal line, y equals some numbers, a horizontal line, so all the points on that line have a y coordinate of negative 2. Okay? And then we practiced writing some equations in different forms, in the slope-intercept form, maybe probably given different things that they gave us, points and lines, or points and slopes and so on. Then we were able to write an equation for that line. And then we decided that we could tell without graphing whether or not two lines were parallel or perpendicular or neither by simply looking at their slopes and y-intercepts to see if they're identical equations or if they just differed, they had the same slope and different y-intercepts, in which case they're parallel, or if they had opposite reciprocal slopes, which would mean they're perpendicular. Okay, so this video is posted on Google Classroom along with the assignments for this topic. So enjoy. This is our last topic of Chapter 3, so we'll be looking at some tests in the relatively near future. All right, talk to you later.